today's video, we will be conducting the experiment number 4. The metacentric height apparatus was measured in terms of its mass and dimensions. These parameters are important and must be carefully considered when conducting experiments related to stability of floating body. Now, stability of floating bodies involves understanding how a body behaves when it is displaced from its equilibrium position in a fluid. It is closely related to the position of 3 key points: the center of gravity, or the G, the center of buoyancy, B, and the metacenter, or denoted as M. Then, the center of gravity is the point at which the weight of the body acts, while the center of buoyancy is the point through which the buoyant force, equal to the weight of the displaced fluid, acts. The metacenter is the point where the line of action of buoyant force intersects the vertical axis of the body when it is tilted by a small angle. Now, if the metacenter is above the center of gravity, the body tends to return to its original position after being disturbed. This condition indicates a stable equilibrium. Sumusunod lang ko sa nakatilt yung barko. Ay, this is called metacentric height na nga pala eh. Pag sinagad natin,
ito talaga yung pinaka-highest na tilt na 20.
Yeah. Tapos, since andito yung center of gravity niya, nagtapat din sila ng binat ngayon. At anong degree yun?
Ay, gitna.
Yeah, probably 18 degrees.
18 na 19.
Oh, ganun.
Next.
Oh, paano na?
Siyempre ba talaga?
Since nasa sentro din siya, nasa center din natin yung location ng pinaka. Sagat natin ulit dito. Hindi siya lumulubog, pero at 5 seconds, lulubog yan.
Pero hindi yun nakabubog. Kasi nasa baba siya.
Galing, galing talaga sa bata.
On the other
other hand, if the metacenter is below the center of gravity, the body will continue to tilt, indicating an unstable equilibrium. We also demonstrated the effects of shifting the center of gravity on the metacentric height. As mentioned earlier, when the center of gravity is raised, the floating body becomes less stable. In the experiment or in the video shown, as the center of gravity was moved higher, the body began to tilt and in some cases continued tilting until it became partially or fully submerged by the water. Now, this tilting movement was carefully measured by recording the angle of tilt. Using this data, we were able to calculate the metacentric height, which is a quantitative indicator of a floating body's stability. Now, when the metacenter coincides with the center of gravity, the body is in neutral equilibrium, meaning it remains in its new position after disturbance without returning or capsizing. The takeaway is that the greater the metacentric height, the more stable the body is. Therefore, when adjusting the center of gravity, it plays a crucial or a critical role in influencing whether a floating object remains stable or unstable.